Now, the ways that we keep our infrastructure very efficient is by tightly packing customers together. Either virtual machines, and that technology has been around for a long time. More recently, within the last decade, we've introduced hypervisor-based isolation for containers with Hyper-V. So you can see that in the middle. And those address traditional OS-based applications, containerized applications, but we really see a place for user-defined functions, small functions that will execute either in the network data plane, like on a front door service, or as a user-defined function sitting inside of a storage service. But we need to strongly isolate them as well. And WASM, while it has a great sandboxing technology and it's really got a great ecosystem around it, lacks the kind of isolation that we require for running a public cloud. So we've been working on how to solve this problem. And we've come up with something we call a micro VM, which can isolate tiny sandbox, create tiny sandboxes, whether WASM or some other runtime, and strongly isolate them with the guarantees we need on top of the same hypervisor stack. Hyperlight works by giving an application the ability to go create a micro sandbox, a micro virtual machine, load some code into it, and then call that code. And let's go see just how awesome this is. This is one of my favorite demos here. So here I'm going to show you, I've got running on a Linux machine. Linux DOM 0 is what we call Linux as the host partition for Hyper-V, and you can see Microsoft Hypervisor there. If I take a look at the amount of free RAM on this system, you can see or the used RAM, it's got 1.1 gigabyte used. Now I'm going to kick off a script that it's going to launch 2,000 micro VMs. And it did it, and you can see it did it in less than 2 seconds. I've got 2,000 micro sandboxes running on this VM. And if I go take a look at how much memory I've consumed, each one of those is just about 300 megabytes in size. So tiny, able to handle user-defined function. Now I'm going to make some function calls just to show you that this is kind of performance that's close to just calling another function across a process. But I'm actually calling into a virtual machine. And you can see the latency was about 250 microseconds. And as far as programming models, we want to make it really easy for people to create these. So here's a Blazor app, which is a website that says hello and prints a request count, which is a static variable. And if I launch this, there it is, running on plain vanilla OS. And if I do refreshes, every time I refresh, I'm going to see the request count go up because that's a static variable that's increasing. So let's say that I want to strongly isolate that code. I'm going to use the Hyperlight isolator. And it's as easy as invoking that chunk of code and giving it to Hyperlight to put it in a sandbox. And now, each time I call invoke, a new micro VM is going to be created from scratch, which means none of these are going to share any state with any other. There it is running WASM. And if I do refreshes now, that count stays the same, which is because each one of those is a fresh micro VM. So that's the kind of programming model that we're creating for this thing.